right, good morning and welcome to this webinar on improving insurance modeling workflows using MATLAB. To start with, we will get into introductions. Paula, you can take it away.
Hi, hello to everyone and welcome. My name is Paula. I am application engineer at MATLAB and specialize in the insurance industry.
Thank you, Paula. And myself, my name is Mbaima Prisa, and I'm a consultant at Optimum Solutions. I have an honors degree in computational and applied maths, and my interests are in risk management, as well as my research is around that too. So to start with, we'll look at what we're going to be talking about during this webinar. So we'll look at how MATLAB is used in the insurance industry, a streamlined model development workflow, some model examples of insurance risk, as well as model and data governance. All right, so how is MATLAB used in the insurance industry? Right, we can look at price risk. So analyzing the risk that the value of our contracts would decrease, and then identifying the clientele we'd like, as well as predicting insurance fraud and looking at sorting high volumes of insurance claims by agency. So our claims triage and to set assumptions and reserves. So we can look at this case study by the Swiss Re. So they wanted to look at the prediction of loss due to natural disasters. The challenge was to create a prototype that accurately estimates loss using historical and simulated data. They used MATLAB in order to input their data, perform the analysis, as well as deliver that prototype. Right, and the results from that they managed to do a complex analysis on the tasks that they had, and that was all addressed in MATLAB. Their development time reduced by 50%, as well as function speed increased. Right. So we'll look at a model development workflow. So we want to be able to access and explore our data, right? This is data of different types as well as from different sources. So we want to be able to get that data, and we want to pre-process that data. We want to look at noisy data. We want to look at transforming our data to get it ready for model development, as well as extract the features that would particularly like to develop. And then we want to create a model. If we have created that model, we want to also be able to then validate that model. And lastly, we would like to then be able to share that model for it to be used on a day-to-day basis. So we want to integrate the analytics. So some key takeaways we can have from this webinar is we want to see how MATLAB can help us process more data, how we use the existing functionality in MATLAB as well as other programming languages. We want to look at how we can reduce manual code writing and be able to share our work with a wider audience easily. Right. So the first thing we'll look at is accessing and exploring data. So data comes in many forms, and regardless of the type, structure, and location, MATLAB can process the data. So data can be accessed from different cloud sources, as well as big data systems like Hadoop. So in terms of big data, MATLAB has two arrays. So two arrays are useful when we're working with data that is too large to fit in memory. So this can be many files on your desktop, data spread across clusters, or with big data systems like Hadoop, as mentioned previously. So using two arrays, MATLAB allows us to process data in chunks, and with this, we can use all the functionality that you would for a normal array. So in terms of the data pre-processing, MATLAB has an importing tool as well as a data cleaning application that allows you to interactively, without coding it, or get your data into the state you'd like to model it. So you can also generate code for reuse and automation from this. And then for documentation, MATLAB has live scripts that allow you to combine code with formatted text, equations, and images in a single environment. These live scripts also store and they display output alongside the code. And then we also have live editor tasks, which are apps in your live script that help reduce development time. There's a number of pre-built functions that we also use for modeling and applications for AI, and all these are extensively documented to make your work easier. Again, this is all functionality that would work just as well on big data. So we'll now look at a demo, so replicating portfolios in insurance. Right. So what we want to do is we want to find a set of replicating instruments that will capture the risk profile of an insurance contract, right? So we, under all scenarios, want to match a given set of replicating instruments, our A's, to the net present value of our cash flows in our insurance contract, our L's, and we want to minimize the error, the E, using the weights, which is our W, right? So this is how we find a good combination of assets to use for replications. So what we'll look at doing is getting the set of weights for our replicating instruments in our demo. And this is an optimization problem. This is something really easy to do in MATLAB. And this is something that can also be run in less than a second. So we will now go into MATLAB. Right. So our main script that runs the demo is a live script. And as we've mentioned before, you see that we can combine text and data as well as the output in our main script, right? So to reiterate, we want to map the risk profile of our life insurance contract into a set of simple market replicating instruments, right? So our main assumptions in this demo is that the liabilities have already been calculated. So we launched the replication by calling hedge and pointing out the data type to the data path. So we will now open hedge. Right. So this is hedge, which is a class. So the demo uses an object-oriented approach, which is a design approach that enables you to programmatically define structures, code objects, and this allows you to combine your data together as well as functions that operate on the data. So hedge creates replicating portfolios of a set of liability cash flows using predefined replication instruments. This demo uses zero coupon bonds and equity options as replicating instruments, right? So in our properties, we have our A and our L, as mentioned previously. So our A, our replicating instruments, and L, the net present value of our cash flows. So to start with, we'll load our pre-calculated scenario data, so which is what we have in this MET file. So we can look at what this data is. So if we load that into the workspace and we open that, so this is our scenario data. So you see that we have a 3-dimension matrix, 173 points in time, and we have 3 assets and 1,000 scenarios. So this is what we have for our scenarios, right? We also then load our time steps. So we'll open our time steps, and this is basically the time. So our time steps from 0 to 172. And those are the time steps that we'll use, right? And then lastly, we will look at the liabilities, right? So our assumption in this demo, our main assumption is that we have our liabilities calculated already, and we can then look at those liabilities. And if we open this, right, you'll find that we have this matrix here as a 173 times 1,000. So we have 173 time steps, and that the 1,000 accounts for our scenarios. And in this case, we only have one liability vector, right? So we don't have a 3-dimension matrix. right? So once we have the liabilities, we want to then create our replicating instruments, right? So we then create zero coupon bonds and the equity put options using hedge securities, right? So we'll open hedge securities, which is another class that we have to then create the replicating instruments, right? So our hedge security, in our hedge security, we need a name, a type, the maturity, as well as the strike in order to get our replicating instruments, right? So we have two cases. We have a case for solving our fixed cash flows, which just takes the notional amount, and this is what we get for our zero bonds, zero. And then we also have for the put option that we have a strike price minus the underlying stock's current price, and this is what we get from our scenario data. Right? So this is how we then get our replicating instruments. And then if we go back into hedge, we have here that we have securities, which is then that calculation of our replication instruments, and then A is then the present value of our securities, right? And then once we have our A, we can now perform the optimization, right? So here we have X, which is our weight, and this is what we want to calculate. And we have again our A here as well as our L. So L is the present value of our liability cash flows, and A our replicating instruments, right? So in this case, we use a backslash to perform the optimization, but MATLAB has other functionality around this that we could also use. So there are a lot of options to how you can do that, right? And then lastly, we can look at getting our R squared, right? So that we can analyze the effectiveness of our hedge, right? We will then go back into our live script just to look at those results, right? So these are the results that we get from these are the properties that we have from our object hedge. And you'll find that after running hedge, we have our R squared coming through here as 99%, which is quite a high value. And this tells us that we have our replicating portfolio captures the risk profile very well, right? And then we also have our replicating portfolio here. This is what we see here, and this is there. And to the right, you have the weights that are coming through there. And then lastly, when we look at our scatter plot, we see that our 1,000 points, one per scenario, are right on our 45-degree line. And this tells us that our scenario matches the net present value of the insurance contract. So the hedge is good. And this is the end of our replicating portfolios demo. And now I will hand over to Paula to take us through the rest of the webinar.
Thanks, Vinbai. I'll be sharing my screen. Second, please. Okay, so after we've seen the examples and introduction to our tools that Vinbai has done, we'll look another example. Well, more than the example itself, we're not going to go through the demo. We'll see what capabilities you have. So when we think about incident risk, we can think on the life side about mortality model. We have included as part of our risk management functionality, some life tables functionality. So you can fit algorithms like Heligman, Polar, and so on. And also, although you won't see as part of tools, we have ready a demo-only Carter. So you will see stochastic calculations and discuss or pass it on to you if you wish. If we think about the on life, have also included as part of our claims estimations methods. consider change that are expected claims to Ferguson and Cape Cod. So you can just go to our webpage and have a look in the documentation. You search for risk management and claims estimation methods, or even you can, and it will take you to it. Another user story. So these are testimonies that industry is saying about how MATLAB has helped them. Here we have a PCU saying how they had the challenge to comply with the Euro Solvency II to calculate the capitals and also the market risk. So they say how even if there were no programmers, they developed quickly the models, and I mean Monte Carlo simulations sometimes can take a long time. MATLAB, the way it is structured underneath, does this very fast. Also, they have to take it from prototyping to production, and you don't need to be recoding or anything. Just by the click of a button, you can just directly transform programs to something that IT can connect directly to their solution. So that's why it mentions a production system delivered by non-programmer. And also it says calculation times cut by up to 85%. So the way MATLAB is structured inside, it makes it very fast. And also possibilities that I will mention briefly later, like parallelizing your calculations. In this case, with Monte Carlo, it's as simple as if you have a loop for going through all the scenarios, you can just write par, which means parallel, PARFOR, parallel for, and immediately it will use as many cores as you have in your machine. Use other computers. Just before going to this, just mention at the end of the presentation, I will give you some tips about where can you find resources to train yourself in doing what these users say. So they say they handle data very easily. So I will give you some tips. How can you get trained? Sources we offer, so you can get to do exactly the same in a very easy way. Okay, as you can see here, we go into climate risk. These days, everybody's talking about climate, and it's a very important issue because affects everybody. In particular, if we think about the insurance industry, we can think about what losses we may expect have to pay out for losses. Might as well be aware of, or maybe. So it's interesting to include this into our model. Also, if we think from view, when we hold assets, to take into account that those assets are green, belong to green companies. So that's another kind of way of looking at climate. I'm only giving you here to view, but just be aware that we have plenty more information in our webpage, so you can also. Okay, so this example, as you see, we're gonna see that up, and what we're gonna be looking. Pay attention to the physical risk, where we just see the frequent and adverse natural events, flooding, droughts, earthquakes, and all sorts of disasters out there. We see more and more. And then the transition risk. Measures governments taking, and at what pace, how we're using the technologies for this. So what we do here is gonna load a portfolio of mortgages, and then out of that, analyze what is the current state and what the evolution will be. Think about the evolution. Here you can see that you can enter any algorithm. So each of you may belong to a different entity with different predictive algorithms. So it doesn't matter, you can just call. So I will show you how the whole structure is set, and then you can just plug your customize that. So in here, as we say in the slide, it says how to process climate data to extract valuable insight and produce efficient models. So The data is going to come from two sources. One of them from databases, which in this case, I will choose which country because each country will hold different HTTP addresses where you can go and download public datasets, for example, as in this case, or you can have private data sources. So in this case, we have the possibility to choose between France and UK. It's just the same if you want to add, you'll have your own database. So according to where told about, the disaster will be different. So for example, I am based in Spain, and in Spain, we don't get, thank God, earthquakes, but we do get, for example, a forest burn, wildfires, for example. In other places, they'll have loads of flooding and so on. So that's why it will be a bit of different of what event. So I will go into, and then I will see how, as it says, how to boost end user productivity by showing the results. So the idea is that underneath MATLAB, and then you can call it from an app, and you can do just sensitivities, choosing, filtering, and so on. So the developers do it, and then you can share it just by converting this app into a web app. Again, I'll show you briefly later, but the idea is once you have the app, just click a button within the app environment, and it converts into a web app. All you have to do after that is to handle the URL that web app to whoever to share it with, and they will be able to run the web installing it. So let's have a look. Okay, so I've got an app, MATLAB, which is called Portfolio. Before I show you, for those of you who in MATLAB, you can generate apps. You can just come here and say new app, and you can start from scratch. So that you just drag and drop. Just click on a new app, and here all you have to do is you have to add icons. So I add the axis. It's hiding from me. Okay, so I add the axis, I add the push button. And then if I run it now, nothing is going to happen because there is no functionality. Run it now. Nothing happened. But then I can just go and add functionality. I can just go and say callback, add push button callback. And here I can say things like return report and return file sample. And then I can say plot. This app could be really complex, and in that sense, you could put as many axes as you want. But in this case, we just had one, so I will choose that particular axis. It's called this one. APP, be the name. Here. And then if I run it now, I've done something wrong. Oh yeah, so it doesn't recognize. I've done another error. Anyway, I don't want to waste time looking. But you just plot the variable onto the axis, and then it should run and show the functionality. So the idea is you designed the app, and then you assign functionality through this code. So as you can see, you don't have to code anything. The app does it for you. Just include the functionality. Okay, so creating an app that way, we have this one. And here it tells me to choose my region, as I said before. So I choose France. And then I import the portfolios. I may have several different files. This is what I have. This directory, I have this portfolio, which is the one I want to use now. So I select my portfolio. And here it is. I could have more, so I can import more. In this case, these are all the properties that are in my portfolio of properties. So I select this one. If you have more, you can select one, then the other one, and do different calculations, switching from one to the other. Okay, so you can see here, each asset reference, it says is of type domestic, so it just houses from. And then these are the address postcode and the energy efficiency. So this is something that we have a function that the address and it gives you the energy rating. And the same, you can get the flood risk. So this is the value of the property, and this is the loan. This is the loan to value ratio. So what happens is, if we think about climate, we may want to do some changes to the property. So say if we prepare it, if it's risky, it's near a river and it has a high flood, and I want to do some changes, then my property value may go up. And then maybe I need to increase my loan to be able to do those changes to my property. So the loan as well, and the ratio will change. So depending on what I do or what I don't, all this can change. So what I mean is, as of now, which is on x-axis down here now, that's the photograph now. But then when I do scenarios, and this is where I say you can just plug in any prediction that you want. You can say, assuming we do certain changes, assuming we invest this much money, then the prediction for my asset value will be this, and for my flood risk. So if you have algorithms, then it will show here. And if you say flood, you can say anything, wildfire, earthquakes, and so on. Okay, so yeah, I have clicked here, and you can see this metadata. So remember, I mentioned before that we were going to read data from databases, or so this data that you see here, we got it from a map. So we have mapping functionality in our mapping toolbox. And when you access a point in the map, you get loads of information. Some of that might be useful and some may not. So all this data we got just as easy as that with one call from the mapping toolbox. Okay, so when we talk about accessing the databases, you can just use access a database. You can use our data functionality, or you can just call a REST API. So this call REST API is a very general way of connecting software, and it can be very useful. You can try. Okay, and also we are using our visualization functionalities, as you can see in the map here. Okay, so say if I go and say do some sensitivities for the physical scenarios, generating the projection. So here I can do it as it says here, orderly, disorderly, or hot house. Let's say if I go to 2037, if I go to 2062, as you can see by then, the loan to value is nothing. So by that time, probably everything have expired. They have been paid off, and some of them may. What happens if I say disorderly? Disorderly means, okay, orderly is little by little, measures are being taken. Disorderly is all in one go. I don't do anything, and then suddenly I do. And hot house is I just thing, and let's see what happens. So as you can see, medium will go to high and low will go to medium. Disaster will be just happening. And what happens if I go at the transition scenarios? Well, you see all green because I am in 2067 and I am very optimistic. So my algorithm says that if we slowly take measures accordingly, as we say here orderly, then by 2067 everything will be. And I guess if I go further, it might be even A. So that is what my algorithm predicts if we do things properly. If I go back, so we are not as far as 2067, still things are okay. So if I go disorderly, so everything in one go, I will get good results as well, and even earlier, but probably the cost is a lot higher. So all these calculations will have to look, and as I said, probably the cost is high. And if I say hot house, so we don't do anything, then of course things just carry on back. You can see, so no green looking ahead. So this, as I mentioned, is you may think, how do I achieve this? Well, you saw briefly how we create a little app. The apps can be as you want. Very simple to create them. You do drag and drop and assign MATLAB functionality. So those .m's, which are the functions, the programs, like Vivi was showing in the previous example, or the .mlx, which is the new editor that we had a few weeks. Then you program those and you can call them, call anything on your app. Even you can connect to your remote data sources from the app. So you put a button that reads, another button that does calculations, and another button that can do, for example. So once you have the app, sorry, and also when I say you call the databases or the data, as I said before, you can use database functions, you can use APIs and so on. You can use functions from the mapping toolbox and then use a plot, and it will show this here. So those are very easy ways of. Okay, this app has been run within my equally. I could have just come here and say, I could have come here, web app compiler. So what it is this is a transformer app. So all I have to do is to pick up the apps, then say package. It will take a few minutes, and then when it finishes, it will have created something called appi.ctf. Sorry, app1.ctf, whatever name you choose. In that file, I give it to IT, and they will place it somewhere safe. That means it's centralized. That's all it means. So the IT department will server software, and just by placing that file in that directory, it will be ready that you want. So you give them the URL to this app, and okay, simple as that. Okay, I mean, if you have questions at the end of the presentation, you can write them in the chat, ask open to finish the presentation. Okay, as I mentioned before, you can do as I just showed, stress testing the portfolio and see what the losses are and so on, thinking about risk, or we can think about how we invest and include our ESG scoring in our portfolio to take in account not only of returns and risk, but also ESG scores. So we can think of three things. Do we believe the ESG scores that are available to us in the market? Do we want to calculate them? You know, it's controversial. Then what ESG strategies we do? I mean, we can just have normal strategies as usual when you invest. take into account ESG strategies. We have examples that we can show you. And in fact, you can even go and look yourself. Again, if you go with MATLAB, the documentation, and you search for ESG, you will see examples of how to include ESG for optimization. And otherwise, please get in touch with us. And then finally, when you have your strategies set, you can go into ESG report. So there are many ways to report within. As you saw, Binbai was showing you device.mlx. The .mlx, which is the editor within app, allows you to just include pictures, include equations, and so on. So if you just type clean, it's a report by itself because it allows you to hide the code and so on. Even allows you to insert apps, little apps. So it can be like a storyteller by itself. If you want to go further and have a template, then you just define a template in Word, not to do with MATLAB, and then from MATLAB, do the calculations and just put it in the template. Very easy. So just for you to be aware, because all this is towards automating our cash flows. Okay, so I mentioned before about the point ESG scores. You may choose to believe it or you may choose to do it yourself. So as it says here, NLP models can identify committed to ESG. So just for you to be aware, we have NLP functionality, plenty of it. We have text analytics that so share with you and see how you could work through it to get your models to analyze this data and structured data files. You want to proceed this way. Okay, we're talking about different possibilities and algorithms. Something, let me go back because it will be in relation to this. When I said NLP, we enter into machine learning, deep learning, because when you work with text, you can either carry on in the text area and use some algorithms like LDA. You may go into transform with dictionaries and transform into numbers, and then go into training, some machine learning. Then in all these areas, just let you know, as well as the areas as such, for regulation to be able to explain. So let me point you towards that explainability. Also, I mean, let's try to tell you resources. We have also in mathworks.com/videos, you can search for explainability and very interesting video. Also, you can find any little videos, 2 minutes, 5, or even an hour, depending. If you go to /videos and search about anything that Binbai has been saying now. It's all very technical. So all these areas we talk about big data. So I mentioned to you before that you have tall arrays when you data that doesn't fit into memory. And because all that takes time, we offer this parallel computing functionality. And I say here cluster because you can either use the parallel computing with your machine. May have, I don't know, up to 12 or 16 cores, and you may want to use them, all of them. So it means, for example, in the previous case, like PSU user story, they were using Monte Carlo. And as I said, one way is the 4 converting to a par 4. You can either launch it in your machine or you can send it away. So it happens in a powerful server. And when it finishes, you pick it up. All to do is to choose in a little icon whether machine or further cluster. That's all. So the head node will distribute the work, and then all the when they finish. So just keep aware of this functionality. And the same if you have data doesn't fit in memory, the tall array will help, and also we have distributed arrays. So it means you think everything is happening in your machine. In reality, if you define a cluster, it will send a bit of an array quarter saying one machine, another quarter, another machine, another quarter, and so on. So you don't realize your algorithm doesn't apparently, but MATLAB is programmed so it handles everything and same as with the tool. Okay, so we mentioned about creating the algorithm. We mentioned about making it faster or even possible to work on data that doesn't fit in. And then the next step is to take it to production. So there are different ways. One way is MATLAB production server. What this is, you know, when I mentioned before with app, I went to the apps and chose web app compiler. That is when you want to share functionality with a front end to share your user interface. What happens if you only want to share a function? Come here, production server compiler, and I do exactly the same. I add, well, if it is with Excel, I will come here. If it is with other software, so for example, at the moment I'm working with a customer that do the calculations and they give it to 50 people, 50. So they do it as an Excel add-in. So they come here, well, they come to another place similar to this, and either they give you as an Excel add-in one by one, or they do it this way. If they do it this way, they just choose the function that, let's say, is calculation of bar. So I come here, I choose calculation of bar, open. Then when go a package, what will happen is that that calculation bar is a MATLAB be converted into a file called. So from that moment, you give that CTF to IT, they place it safely somewhere, and then the 50 actuaries or the 50 from their Excel, they call that calculation bar. They don't have to do anything. Just call it. So they think it's a function in Excel, but it's not. So it's as simple as that. Convert your function in MATLAB into something that displays safely in a directory assigned by IT. So this is what is called a MATLAB production server. Because it's a server, so it's a software that is running. IT just puts it to run, and then when you develop a model, you give it to them, place it in a directory. You may have 100 algorithms. Then all the users, they just call them from either Excel or from Java, from a web page. I mean, anything that can issue a HTTP. So it's very, very. This is the alternative. I mean, that means functionality. And the other one, the web app server, is another way of taking to production, but with a front end. So you don't only share that function, but you share also user interface. Please let me know if you have any questions, because obviously it's a bit abstract. We show you step by step all this. So I'm very happy to. Interoperability. It's important to notice that that MATLAB can talk to many other. So as I mentioned before, it can read from databases. So namely can be MongoDB, can be accessed on many other Neo4j for graph and so on, SQL. So functions are ready. So with one instruction, you can just call it. And MATLAB can even help you to create SQL queries. So the way MATLAB works is it has a lot of interactive environment for development, then converts into code, and then that is to read data. So you can example, say you have calculation that you want to put in a and show it with Power BI. So we have created links in a way that you use Power BI as the output, and it calls MATLAB calculations. Also, it's very important to say that MATLAB runs in the cloud, which means you can, if you want to develop in the cloud, this means you don't install MATLAB in your machine, you install it in the cloud, and you just access when you want it. Amazon or Azure or charge you when you need it. So that is developing the cloud, and the alternative could be to run in the cloud. So when I create my algorithm and convert it into an executable or into an Excel add-in or into, as we said, with the production server, then that result, that CTF, is in the cloud or the app. When that CTF will be, and anybody can pull it from there, from their own see. And as you see, Docker, Kubernetes will all be. So we have images ready. So if you want to install MATLAB in the cloud, all you have to do is to load it. MATLAB has it ready, and it can be customized as you wish. You see Jenkins as well. We see very, very common in our customers to automate the whole process. So you have big entities developing a lot of calculations, develop, check that they're proper. So you test, unit testing, and so on. And if it's correct, you deploy to production. And all this is done in an automated way to be doing it yourself. MATLAB will run the unit test and let you know, hey, it's a problem here, and it's because of this. So you can go and check it. And you can see we interact with Python as well. We can also interact with C, R, Java, and so on. So from MATLAB, you may think there is a Python algorithm or R, and the other way around. Well, call it with a MATLAB license or without MATLAB. Because if somebody has created an algorithm, converted into a Python module, say, or function, then it can be called from Python without having to pay. So it's just through our compiler functionality. Okay, so now we think, okay, we have models, we've seen how to develop them, how to make them fast, how to take them to production. But the regulators are there, and they tell us to do this in a proper way, clean way, to have governance procedures and so on. So to make our life easier and to have as little model risk as possible and cleaner governance, we have developed a tool that covers all different steps. So we need to develop risks interactively. If we do interactively, faster because we just point and click and MATLAB generates it. Also, if I do something, I may as well create some reusable code which can be called. So we have a particularly relevant environment. If you wish that you can choose scriptlets, so you have a list and you say I choose this one, and my colleague chooses exactly the same, so the code is saying we won't be. So that is for development research. Also, we include challenge models. We need to challenge models better than that, and in a collaborative way. So as I said before, our development environment is like a little story maker. So if you look at the .mlx and you go through it, it will tell you why did you choose one for I chose another one, assumptions. So it will be clear documentation and clear explanation, transparency for regulators. Also, once it's developed and documented, it needs to go to the review. And how do reviewers and developers connect to each other? This tool that we say logs in every action that you do in a way that find anything, any model developing, which status it is, when it's to be reviewed. The reviewer gets an email and it goes and finds, because we have an inventory where you all the issues, logs anything that happened, who clicks on what, status of the model. So that's very easy for you to communicate and find. So once everything is ready, thinking about going to production, we may have a test environment. We need to check if things work properly in the test environment, and as well as in the development environment. And if it does, then we'll go into our deployment. And finally, we have to monitor that everything is still valid. as I mentioned, automate exchange of information logged and from one person. Issues are global. So this is the idea I was describing. We start by developing. So we defined and develop and document. Then an independent reviewer go and pick it up where it stays. So it's a centralized location to find everything, and auditors regulate it and so on. Once the approval is given to the test environment, if you have one, generalization and so on, check that things still work in terms of how to connect to the right databases and in the workflow. Once everything is working, you go, as I said before, transform it into that CTF file, that whatever. See that, it just happens all underneath. And that means it can be used, no operational risk. Code is not available, it's only just to be run. And then you need to monitor it to make sure that, or you may need to recalibrate it and restart again. Okay, and we finish here by saying, I said before that I will tell you some hints about how you can develop what user stories are saying. So our documentation, MATLAB documentation as such, which is the little icon with question mark, the white icon, stop. But also you go to mathworks.com/videos, and also we have little workshops. So our workshops don't have to pay anything. So we through the different content, as you can see here with you, and show you examples and how you can stay about an hour. And also you can go to OnRamp. It's also available free. It's about 2 hours and you have to do the work yourself. Wait, then stop, then carry on working. So if you search, for example, OnRamp MathWorks MATLAB, OnRamp MathWorks Deep Learning, Machine Learning, take you directly there. And of course, it's proper training, which is 2 full days that we guide you through and do exercises. Okay, so from me, I just have to say thank you. I hope it was useful, the session, and please forward any questions that you may have.